Okay, we're going to take a look at graphing exponential functions. This is going to look a little bit different. This is something you guys haven't seen much of before, if at all. So for our first example, we're going to go with y equals 2. Now instead of having the variable anywhere else, the variable is actually going to be the exponent. So it's y equals 2 to the x is going to be our equation here. So what we're going to do, we're going to talk about graphing these in a second, but before we graph them, we need to come up with a table. So we're going to graph this from a table. All right, you got an x and y chart. Now the good news here, we don't have to find a vertex like we did on some of the other stuff recently. We're actually going to plug in the same values for x each time. Now you can check other points, but these are going to be the ones that are kind of the easiest ones to go back to and to work with. So we're going to check -1, 0, 1, and 2. Okay, so those are the points we're going to want to check. You could check a lot of other points, and that would be totally fine, but these are the ones you're going to see what happens on the graph here in just a second. Now, I typically actually start to show students with the one at the bottom, the +2, because that's the one that's sometimes easiest for them to think of as an exponent. So all we're going to do is take 2, and instead of x, 2 to the x power, we're going to be 2 to the, we plug in 2 into that spot where the x is. So 2 squared is equal to 4, so we put a 4 right there. Okay, so that's how I get the point 2, 4, which we'll graph here in a second. All right, 2 to the first power. Okay, I take the 1 and I plug it in right there. 2 to the first power, I get 2. So this will be a 2 right there. All right, and then we keep going. Now this one, sometimes students get in a hurry. They see the 0 and they think, well, 0 must be 0. Anything to the 0 power is actually 1. Right, so be careful on that. So this 0 will be a 1. And then now, 2 to the negative first power. I saved this one for last because this one sometimes gives us a lot of trouble, or at least gives students a lot of trouble. So if you recall, going back to polynomials, negative exponents actually mean that it'll move from, it's like the elevator, it goes up or it goes down. So in this case, this is really, if this is 2 to the negative first over 1, this is going to move down. And we're going to get 1 over 2 to the first power. So this is actually 1/2. So if you want to write it as 1/2, that's fine. For Canvas purposes of doing the homework or a quiz or a test, it's going to be a lot easier. Instead of putting 1/2, you could just put 0.5 or 0.5. So I'm going to put 0.5 right there. Okay, 1/2, 0.5 means the same. There's some ones later, it's just going to be easier to put the decimal, I think, when you type it into the computer. So that's why I show you that. All right. So that's how we get our table. Now we're just going to plot the points and see what this looks like. So we got the point 2, 4. 1, 2, 3, 4 is up here. We got the point 1, 2. We have the point 0, 1, which is going to be right here, just because of the way I put these up makes that tough, but right there, that is 1 point. And then -1 point up 0.5 is right here. So if we kept going with these negative exponents, the negative exponent's just going to flip it and you're going to get a smaller and smaller decimal. So actually what will happen, the shape of this is going to run right along just above the x-axis. It's going to go right here and then it's going to go up. Okay? So the shape of our exponential actually looks like this. So it's not a parabola. It's kind of, it's just an elbow there that goes up and down. Sometimes we compare it to like, an airplane taking off the runway and going straight up. Obviously, that's a pretty steep incline, but that's our shape for exponentials. Okay, so there is number 1. All right, let's keep things moving here. You can pause the video at any point in time. Keep that in mind. If you need me to slow down, just pause it. So, number 2. Y equals 2 to the x power. This one is +3. Okay, so this time, once again, we're going to check -1, 0, 1, and 2 on our x and y table. Okay, I always like to start with this one. You don't have to. You could start with the -1, but in my opinion, that's the most difficult one. So I'm going to go 2. So the 2 goes into the second power +3. So 2 squared is 4 + 3. So 4 + 3 is 7. So I'm going to get a 7 right there. Okay, so then I go to 2 to the first power +3. So now this +3 part, all it does is it changes obviously these y values, unlike the last question we did. It's almost the same. It's the same base right here. Here we get 2 + 3. So this one's going to be 5. We've got 2 to the 0 power plus 3. Anything to the 0 power is not 0, it is 1 plus the 3, so this one is 4. And then finally 2 to the negative first power plus 3. We just did that one, so a negative exponent changes it to 1/2 plus 3, so that's equal to 3. I'll write it as 3.5 here, but for Canvas purposes and typing it in, I would write it as 3.5. Okay, so let's take a look at where these end up on the graph. We've got the point 2, 7 is up here. We have the point 1, 5 right there. 0, 4 is right here. I need to fix those a little bit. This is right, it goes through right there. And then -1, positive 3.5. Now this one, because of the plus 3, this would just keep becoming a smaller and smaller fraction added on to 3. So we're never actually going to cross this line. So a lot of times I tell students, you can go ahead and draw this line, whatever this number is plus 3, it's not going to cross that horizontal line, whatever that is. So our exponential graph would run right along here. It's going to go, well, through this point and take off. So there you go. So it's actually the same graph we just did, shifted up 3 spaces. Okay, so there's our first 2 examples. We got 2 more. All right. Okay, for number 3, let's see, for number 3, where am I at? For this one, we are going to do y equals 2 times 4 to the x power minus 7. All right, so obviously we're stepping things up a little bit here. We can still check the same points that we checked before. We're still going to check -1, 0, 1, and 2. We got x, we got y. Right? This one would be, in my opinion, this is about as tough as it gets. Okay? So hang in there with this. We're just going to substitute the 2 in right there. Okay, so this one I'm really just going to fill out the table. I'm not actually going to graph this one, but I want to show you the table. All right, so we get 2 times 4 to the 2nd power minus 7. Okay, so 4 squared is 16, so we end up with 2 times 16 minus 7. That's going to be 32 minus 7. So that one is 25. Well, we'll see if we end up on the graph. We actually, part of this will be on the graph, so we'll still put them on there. But the main thing is figuring out this table from this. So I took the 2, that's why it is right here. Okay, 4 squared is 16. 2 times the 16 is how I got 32, and 32 minus 7 is where that comes from. So now we go 2 times 4 to the 1st power minus 7. Well, that's a little bit easier. 4 to the 1st power is just 4, times 2 is 8. 8 minus 7 is 1. So quite a big jump there. Now we go 2 times 4 to the 0 power minus 7. Now, sometimes students get confused on this, but if you cover this up, 4 to the 0 power is 1. So we really have 2 times 1 minus 7, which is 2 minus 7 to get us -5. So there you go there. And then 2 times 4 to the -1st power minus 7. All right, so again, forget about this for a second. 4 to the -1st is the reciprocal in this case. So we get 2 times 1/4 minus 7. That's 2 times 1/4 is 2/4, which is 1/2. And 1/2 minus 7 is equal to a -6.5, which I'm going to write as a -6.5. So there you go. Now this one will actually be way off the graph, but the others we can actually put down here. And like I said last time, whatever plus or minus this is, shifts it up or down. So in this case, we're going to shift down 7 spaces, and it's never going to cross this spot right there, okay? So the 225, that's way up top. Over 1, up 1, that's right here. 0, -5, that's right here. Okay, and then -1, -6.5 is right here. So this graph would run right along just like the others, and then boom, this takes off quickly. And it goes all the way through the roof there. Okay, So that one, as you can see, if you were to compare that to the other one's right along here and then take off this way. This one runs right along and then basically almost straight up. So when someone says something increases exponentially, it's increasing faster, much like what I'm showing you here. Okay, we got one more to go. Last one. We got to look at what happens if you were to have a negative mixed in with this. Not a negative exponent, but a negative base out front. I guess the base is not negative, but the number part in front of the base is negative. So here we go. For number 4, we have y equals a negative, and then notice the parentheses, 3 to the x. So we're still going to check -1, 0, 1, and 2. Here's x, here's y. Okay. So here we go. The negative is outside the parentheses. So we're going to do 3 squared is 9 times a negative. So we get -9 right here. Notice the negative is not inside the parentheses. Then we go to be -3 to the first power, which that one's pretty fast. We just get -3. So there's that. -3 to the 0 power. Anything that's 0 power is not 0, it is 1. So we get -1. Okay? And then, so plug that one in. -3 to the negative first power. Sometimes students get confused here. They'll put a negative as a positive. Don't think of it like that. A negative exponent means, in this case, we got to take the reciprocal. We get a -1/3. So that's going to be a -1/3 or negative. Technically, it's 0.3 repeating. That one I wouldn't give you on Canvas. Kind of it's tough to write as decimal on Canvas to put the line above. So anyhow. There's our table, so let's see how that looks on the graph. So 2, -9 is all the way down here. 1, -3 is right here. 0, -1 on this little part that I didn't get quite connected there. And then -1, -1/3 is right there. So because it's not plus or minus anything, it's not going to cross the x-axis. So it's going to run right along like this. And then go down. All right, so I was typically joking with students about this. This is like, a positive exponential graph is reality. The negative exponential graph is the upside down, just like in Hawkins, Indiana. There you go. We got the upside down, like in Hawkins. So that is graphing exponential functions. There is a -1 there at the end. You'll see one of those on the homework assignment. If you have any questions, let me know. And hang in there with this, guys. We're getting close to the end. Please reach out with questions. Please, I'm trying to do Canvas conferences if you have questions at all, or if you're struggling, or if you're needing to get caught up, whatever it may be, please send me a message so I can help you out. Okay? Hope you guys are all doing all right. Hope everyone's staying safe, and good luck with this stuff. Let me know if you have questions.